I'll make. Okay, I like this one. Where did it go? Didn't anyone here not eat his or her homework on the way to school? Look at the math. A bone equals a bone and a half. Yeah. Okay. So instead of taking through first principles, we can use first principles, but before we do that, let's actually just look at the graphs. So if I was graphing y equals sine x, and we want to graph the slope, the equation of the slope, or our derivative. So where we have a maximum is now going to be what? What's the slope of our max?
0.
0. So that becomes 0. Well, close. So this is 0 again. This would be max slope, right? Our maximum slope is going to be here. Oh, no. That would be min. Sorry, it's downhill. It's negative. Okay, this would be a minimum. Because we have a negative slope here and a positive slope here. And then a positive slope here. Okay, so when you actually graph y equals sine x and you graph its derivative, it actually is y equals cos x. So the derivative of sine is cos.
Wait, so now it is just like a...
Yeah, right, because what graph is this? This is a cos graph.
Like, you mean the derivative of sine x?
Yeah, derivative of sine x is cos x. Okay, bingo. So if we had cos x, here this is a slope of 0, right? We'd have another slope of 0 here, and another slope of 0 here. Okay? This is a negative slope, and here's our positive slope. So negative and positive. So the derivative of cos is negative sine. You don't have, well, here's the proof. We don't have to.
Wait, so the derivative of sine is cos, but the derivative of cos is not...
Negative sine. It's negative sine.
Well, so what's the derivative of negative sine? Yeah.
Then it'd be negative cos.
No, that doesn't make sense. No, just think sine has the same sign. Cosine has the different sign.
Yeah, just like okay, because if you look here, right, this is going to have a negative slope below the y-axis. Here we have a positive slope above the y-axis. This is negative sine. If you look at sine, because sine goes positive slope, negative slope, positive slope, that's why it's going to be above y-axis, below, above, which is our cos graph. Okay? So if you had the graph negative sine x, it would be negative to positive to negative, so it would be a negative cos. Okay? All right. So let's find this derivative. Oh, can you change this to an x? Otherwise, what would be that slope? 0. It's a constant. So we have to change it to an x. The loophole. Okay. Y equals cos negative 4x. What's the derivative of cos? So cos, close? Right. Sine has the same sign. So cos is negative sine. Keep the inside times the derivative of the inside. Thank you. Oh, Lord. Times the derivative of the inside, which is negative 4. So what does it work out to be?
4 sine negative 4x.
Beautiful.
We're going to have like a...
Okay. Because the negative 4 times the negative sign becomes positive. Yeah, this is a multiplication. Times the derivative of the inside. Okay? Yeah. Okay, so derivative of 4 sine would be 4 cos. Are you guys with me? Okay, so derivative of sine is cos, right? Sine is going to have the same sign. And then what do we have to multiply by? derivative of the inside. So we can simplify this. We'll bring that guy out front. Negative 16x cos of negative 2x squared minus 3. Fun yet? Easy. I know, isn't this nice? Oh, it's about time. It's a great way to finish the week. Derivative of sine is cos, and inside is 3x squared times, what's the derivative of the inside? Yeah, easy. Oh! Okay, what do you want to do with this guy?
It becomes 2 sine.
Yes.
You bring the 2 sine.
Remember, this is the same thing as sine 3x all squared. We just write the square because we're lazy. We don't want to have all these extra brackets. They're ugly. So the derivative here, we have to use the power law first, or chain law. So 2 comes down. We leave the inside of 3x times, what's the derivative of sine 3x? Cos 3x times what? Okay, if you want to get fancy, guys, can I show you something? Yes, come on. Do you recognize this? 2 sine theta cos theta. Yes, 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 yes.
No, don't tie other stuff to this, please.
What is this equivalent to? Grab your formula sheets.
That would be a billion.
That would be sine 2 theta. That's a double angle. So it'd be 3 sine 6x. This 3, right? This 3.
Do we? I don't do that. Will you not press marks if we don't do that?
No, I won't.
What happened to
Okay. Yeah.
Can we always have to assume that this is true every time? What happened to the 2?
Okay, can we assume what? Just
We assume that like this will always happen. Oh, I see now. I don't see what happened to the 2. She did that. What happened to the your 2? Yeah.
yeah, like whenever you're deriving sine squared theta, it's going to be 2 sine theta cos theta times the derivative of theta.
So it's the derivative of the. So it's derivative of theta sine 2 theta.
Yes, the derivative of this.
So it's the inside times 2 and bring the numbers.
Okay. If you left it as 6 sine 3x cos 3x, that would be fine.
Yes, that's what
Unless I say prove that the derivative of this equals 3 sine x. I don't know.
Wait, 3 sine x.
Depends how bored I am. Okay. Ooh. What do we have to use here? Product rule. Okay. So y prime. Derivative of x is? You're thinking of that guy. Okay, so 1. So leave the second guy. Times, or no, not times. Plus, leave the first. Derivative of cos. Negative sine 1 over x.
Wait, why did you give it to x?
Times, we're doing product rule. So this here is actually 1 times. We're doing product rule. Okay? Derivative of x to the negative 1. Because we have to do the derivative of our inside still. Negative x, negative 2. Okay? So we can simplify this to be cos of 1 over x. So if we have a sign here, what's the sign going to be? It's kind of confusing when we're trig and I'm asking what sign. Positive. Because 2 negatives give you positive. Now you have the x divided by x squared. So what will it be? 1 over x. And then sine 1 over x. Because here you had x over x squared. Cool. Right, these two together become 1 over x. The negatives canceled. We had a negative sign and a negative here. Yeah, isn't this awesome? All right, y why don't you try this one? Give this a try. I'll pause it. Okay, it all comes down to this moment. Okay, so y prime, bring down the 6, leave the inside, guys, power of 5, times the derivative of the inside. Now, remember that cos squared x is actually cos x squared. So derivative of 1 would just be 0. The derivative of cos x all squared, well, we have to use the power law again. So 2 cos x times the derivative of cos x is what? Negative sine x. Okay, now if you wanted to get fancy, we can pull this negative out front. And what else could we do if we wanted to be fancy?
You could use that one thing on the green sheet.
No, even more fancier than that.
Use that one thing on the green sheet.
Green sheet, 2 sine x cos x. What does that equal? Sine 2x.
Where is that on the
Okay, that's identity on the front under double identities. Cos, sine 2x right there. You'll get better at this as you get to this in Math 30. Yeah? Pardon me? Sorry, guys, I can't hear Landon. If you left it at negative 12, that's, yeah, you would have left it at negative 12 cos x sine x, that's fine. Yeah, yeah, that's fine too. Okay, this is or. Eyes. All right, last one. Last one. Find the equation of the tangent line at pi over 4 and 1. So what's the first thing we want to find? We know our point. We need our slope. Okay, so, Greg, B, what do I have to use to derive that?
You have to use this thing on the green sheet that's right.
No, nope, nope, nope. Quotient rule. Okay, f prime g minus g prime f all over g squared. You need to know that by heart. It is pretty easy, but okay. So derivative of sine. Wiley, can you put that on my desk? Goes. And then leave the bottom. So we have cos x times cos x minus.
Or cos x squared.
Or cos x squared. Or cos squared x, yeah. Leave the top. Derivative of bottom, cos x. Negative sine x. All over the bottom squared. So, okay, so this is exciting. It is, because cos x times cos x is cos squared x. No, because of the subtraction. Okay, and then we have two negatives, so positive sine squared x, which equals 1. Right? So this is the Pythagorean identity, Pythagoras' identity.
You can only cancel on one side. So it's 1 minus.
We can't just cancel because of the addition.
But you can do 1 minus sine.
You could do, well, it's 1. It's just 1.
Yes.
Right? On your green sheet, the very first one under Pythagorean identities. Sine squared plus cos squared equals 1. Yes.
But you also split it out so that you have cos squared x over cos squared x plus sine squared x over cos squared x.
Ouch. Could you also split out to be cos squared x? Oh, yes, you could also do this. So cos squared x over cos squared x plus sine squared x cos squared x. So you could have also had 1 plus tan squared. Which, what is 1 over cos squared? No, what is 1 over cos?
Cos
Secant squared, right? It's secant. We're going to leave it as, but, and this 1 plus tan is secant squared. So it is all the same. Yeah.
Okay, but I'm really bad at like realizing these things on.
It takes practice.
So you put that next on.
You'll get better, I promise. What? Now we can say, okay, our slope at Slopa. Pi over 4 would then be 1 over cos pi over 4 all squared. Pi over 4? Because it's root 2 over 2. So 2 over 4. So it's half. 1 over root 2 over 2 squared. Which is 1 over, because 2 over 4, so 1 half, which is 2. Sweet. Okay, so now we can get our equation. Y minus y1 equals m times x minus x1. Y minus 1, our slope is 2. Can I just make a note about something though, guys? Because I noticed this in your log stuff as well. When you make your equation, it's really important that it goes x, y, and then the constant. So this would be 2x minus y, and then the order of the constant doesn't matter. So plus 1 minus pi over 2. So let's not cut that off. You have to put, in general form, it's ax plus by plus c equals 0. And a lot of you were putting your y's at the end and not x first, then y. It's just the formal way of doing it. It's true. Okay? Unfortunately, it's the same thing, but it's how we properly write it. Okay.